function notation, it's just another way to write equations and replace the y with f of x. And when we talk about an equation with x and y, x is typically my input and y is my what? Output, right? So we're replacing our output as f of x, which means the output value of the function f for the input value. So if I have, this is not on your notes, if I have, let's say, y equals 7x plus 2, right? And I said x is 2. What would you think to do with that? Plug it in, okay? And what would you replace with 2? X, and you would be solving for the y. So 7 times 2 plus 2, which would give me what? 16. So I can look at this point on a graph as 2, 16, right? The x is 2, the y is 16. If I said x is negative 1, would you do the same thing? Yes, plug it in. 7 times negative 1 plus 2 is y equals negative 5. So my point would be at negative 1, negative 5. Now, if I'm talking about function notation, you're essentially replacing the y with a new way to write it. So you're saying the function of x, where x is the input and f of x is the name of the function. So 7x plus 2. And if I was going to evaluate where my input was 2, instead of saying x is 2, what they're going to write is f of 2. If I look at that and I compare this statement with this statement, what got replaced with 2? X. So you would have the same process. You would say f of 2 equals 7 times 2 plus 2. And you would still get that point on the graph 2, 16. So x is my input, and f of x is my output, or y. Same as y. So if I said f of negative 1, would I get the same scenario that's over here? Yes, right? What did I replace with negative 1? X. Okay? This has nothing to do with multiplying negative 1 by f. This is the name of the function, and this is the input. There is no multiplication involved. So if I look back here, and I go into these examples evaluating given function notation, I've got f of x equals 7x minus 1. So it looks very similar to what I just had, right? I could rewrite this as y equals 7x minus 1, and it would be the same thing. Okay, so now at this point we're all together on the notes, right? So y equals 7x minus 1. They said find f of negative 2. So if I have f of negative 2, what did they replace with negative 2? X. So we have x equals negative 2. So are we going, if we know x is negative 2, am I looking for input or am I looking for output?
Output.
Output. So I take that negative 2 and I replace everywhere I see x with negative 2. So then what will that give me? Negative 15. So y equals negative 15, but the way that we're going to start writing it is f of negative 2 equals negative 15. The function output when the input is negative 2 is negative 15. So if I was going to write that as an ordered pair, if I was going to put it on a graph, what would that ordered pair be? minus 2, minus 15. Okay? Why don't you guys try example 2? What do you think?
Negative 29.
Say it.
Negative 21. Wait, no, I meant
Nathan? Just 2021. Okay, I need to have this conversation with y'all. If you input into your calculator this, your calculator assumes that you are saying this, because exponents and order of operations come first. So they're not taking the negative with it. When you have an input value that is negative that you're plugging in with an exponent, you need to make sure that you use parentheses, or else it will come out wrong. Okay? And you can't say, well, my calculator said, because Ms. Stinchcomb is telling you right now that that's what the calculator does. This is what you need to do. So that being said, if I square negative 5, I get positive 25 minus 4 is 21. So my output, or G of negative 5, equals 21. What would that ordered pair be on the graph? 21. Very good. Okay, so let's take a second and go back here, right? What if I would have come over to this problem and said y equals 9? What would you have done? Plugged it in for what? Y. And I would have solved backwards and gotten my x. So if we have 9 equals 7x plus 2, what would that give me as x? 1. So what's my ordered pair? 1, 9. Right? It's a normal equation. But what it's going to look like over here, remember how I said I replaced x with negative 1, so it would be f of negative 1. If you're using y, it would have looked like this. They would say f of x equals 9. They're saying take this entire piece and replace it with 9. Because my x is still x, so then what am I looking for? I'm looking for what is the value of x. Okay? So let's go back to our notes and scroll down to that bottom half. It says, given h of x equals 5x minus 1, find x if h of x equals 9. So this is basically saying y equals 9. My output is 9. So when I look back at my function, h of x equals 5x minus 1, what am I going to do to solve that? What am I replacing? H of x, this whole piece, not x, because we're trying to find x, right? So this is 9 equals 5x minus 1. We're trying to find x. So what would x be in that scenario? 2. So what is my ordered pair? 2, 9. Okay, let's look at example 4. Given f of x equals negative x plus 2, find x if f of x equals 6. So I'm finding x, which means what is replaced on my function. The f of x, the output. What are we thinking? Sam?
negative 4.
I agree. Negative 4. So what is my ordered pair? Uh-huh. good. Okay, so now flip over to the back. And you guys are going to practice. Some of those are a little bit more challenging than others. When you look at those 4 functions, they all have different titles, right? F of x, g of x, h of x, j of x. So when you're looking through your work, you need to be careful that you choose the correct function. So if I'm looking at letter A, which function would I use for that problem? G. So it says g of 10, so I'm going to use this function to answer that, okay? And you're going to do everything except letter E and stop when you get to this graph down here. So you're doing A, B, C, D, F, G, H, okay? So A, G of 10 is what?
Negative 20.
Negative 29.
29. Why did I think that was
Okay, letter B, F of 3 equals
16?
very good.
Yes.
Letter C, H of negative 2 is
Negative 6.
very good. D, J of 7/4,
12 and a half.
12 and a half, or if you left it as an improper fraction, is 25 over 2. Please don't write it as a mixed number. Mixed numbers are not my friend. Okay, letter F. Find x. If g of x equals 16, what's x? Very good. Find x. If h of x equals negative 2.
Negative 6.
And find x if f of x equals 23. 4. Good. All right, so we spent a lot of time talking about the ordered pairs that would be associated on a graph, right? We spent a lot of time talking about that. First thing I want you to do, eliminate 5 and 6 and 7 and 8. We don't need that. Okay, so if I look when there's a graph given, we're paying a lot of attention to those ordered pairs. So for example, g of 0. If we think back to what we would do up above, g of 0 means that what is 0? X. So 0. Where x is 0, they're looking for y. So when I look at the graph, I'm looking at my x-axis where x is 0, what is y? 3. So the answer to that would be 3. What about g of 4, where x equals 4, y equals 6. G of 6, where g equals 6, 1. Okay, now it says, can you find the x values for which g of x equals 3? So what is 3? What is 3? X or y? Oh. Y. This says y equals 3. So where y equals 3, where does my line touch y equals 3? 0 through 2, right? Again here in between 4 and 5, and where else? 9. So it touches in multiple places. I know for sure at 9. How can I represent something that touches the entire way from 0 to 2? 0 is less than or equal to x is less than or equal to 2. It touches the whole way across. Okay. And then for that next one, it's kind of hard to see exactly where it is, but we could say it's between which 2 values? What 2 values is it between? 4 and 5. Less than 5, greater than 4, somewhere in between there. Okay? How do y'all feel about functions? Good. Okay, so on your test review, you're going to have some time to work on your test review, but looking at functions first, Number 16, I think it's 15 and 16, deal a lot with functions. So if you want to practice those first while it's fresh, that would be where I would start. Okay?